All right, so I've got 3 more examples that we're going to look at. For each one, we're going to determine the domain and range, whether or not the relation is a function, and we're going to think about the x and y intercepts, okay? All right, so let's look at our first guy. This is a domain and range map, okay? Again, the domain on a domain and range map, pretty straightforward. Our domain will just be 1, 3, 0, 7. A lot of people like to write this in order, so 0, 1, 3, 7. I'm okay either way. Our range will be -2, 4, -6, 0. Okay? And then let's decide whether or not this is a function. So in order for something to be a function, our domain elements can't do double duty. Notice that each domain element only has one line coming out of it. That means no domain element is mapping to 2 different range elements. So yes, this is a function. And last, we're going to look for x and y intercepts. Okay? Now remember, x-intercepts have that form, a number 0. In other words, the y-coordinate is 0. So range is our y value, so notice that we have a 0 here. So this, whatever this is going to be part of an x-intercept. Now, what is this as an ordered pair? Well, this has domain 7 and range 0, so this is the ordered pair 7, 0, and this is an x-intercept. Okay. Similarly, remember that y-intercepts have the form 0, a number. So we're looking for 0 in the domain spot or 0 in the x spot. Here's a 0 in the x spot. So we've got the ordered pair 0, which is mapping to -6. So 0, -6, and that's a y-intercept. Okay. Now let's come over to this guy. So first thing we want to do is decide the domain and range of this. So the domain here is our x numbers, our numbers in the first spot, okay? So our domain is going to be -3, -2, 0, 2, 3, -3, -2, 0, 2, 3. And our range will be all of the numbers in the second spot. 2, 1, 4, 1, 0, 2, 1, 4, 2, 1, 4. I don't need to repeat 1, 0. Okay. Now, is this a function? In order to be a function, no domain element can do double duty. None of our domain elements are mapping to 2 range elements. So, yep, this guy's a function too. Okay. And last, for this, we're going to look for x and y intercepts. So remember, x-intercepts have the form a number 0. Well, right here, we have that. So here is an x-intercept. Y-intercepts have the form 0, a number. So here is our y-intercept. Now notice in both of these examples, there was an x-intercept and a y-intercept. That's not always the case. Something cannot have an x-intercept or not have a y-intercept. That's okay. All right, last, we've got our challenge problem over here. Okay, so this is what's known as a piecewise defined function, meaning it's defined in pieces. We've got this piece, and this piece. Okay, now we're actually going to work this one backwards. We're going to find the x and y intercepts, find the function, and then find the domain and range. Okay, so let's start with x-intercepts and y-intercepts. X-intercepts are any place this crosses the x-axis. So here's our x-intercept here. So our x-intercept happens right here at -3, 0. Y-intercepts are any place this graph crosses the y-axis. That's right here. So our y-intercept is going to be at 0, 2. Okay. Now let's answer the question, is this a function? The easiest way to tell whether or not a graph is a function is to use the vertical line test. Okay. Well, any place I were to draw a vertical line would only pass through the graph once, which means yes, this is a function. Okay. All right. Last but not least, let's think about the domain and range. I said this is going to be our challenge problem for the domain and range, and it certainly is. Now remember that our domain deals with the x values, okay? Or any place along our horizontal axis that is associated with graph, okay? So I don't have any x values here. I'd start having x values here. And I'm drawing an open circle because I see an open circle there. I have x values until I get to here. Ooh, open circle there. All the way to here. And then I've got a gap, right? There's no x values here. So then my domain would start again like this. So my domain is also defined piecewise, which is kind of a pain, right? I've got this piece of my domain, this piece of my domain, and this piece of my domain. Now that may look kind of confusing, but take it step by step. Let's write a description of this piece of the domain. This piece is going from -4 to -2. We know how to write that. -4 to -2. It doesn't include -4, that's an open circle. It doesn't include -2, that's an open circle. Okay, and then let's write this piece. This piece goes from -2 to 1. It doesn't include -2, that's an open circle. It does include 1, that means a bracket. And then we join these two pieces with the mathematical and, which is the union symbol. Now we're not quite done. I have to union that with this last piece. This last piece says 3 to infinity. 3 to infinity. 3 has an open circle. Infinity, we never include. So our domain is defined in 3 pieces. This piece, and this piece. If you look at each piece separately, it's not so bad to write. Let's see if we can do the same thing with our range. Okay. Our range is our x values. Sorry, that's not true. Our range is our y values. Okay. So I start having y values here. I have y values, I have y values, I have y values. Now here, at y equals 2, there's an open circle here, but that's okay. I don't need to worry about that open circle or this open circle because I have graph defined. In other words, there's a point on this graph, say right here, that has y value 2. This is the point 1, 2. Okay. And so this is going to continue on forever. Okay. So our range is going to start here at -2 and go forever or until infinity. At -2, that's just an open circle. So that'll be parenthesis -2 to parenthesis infinity because we never include infinity. Okay. So finding domain and range of piecewise defined functions is a little tricky. We're going to practice that more later on.